Greetings from Berlin, Germany. I am very honored to be an invited speaker at the 9th International Conference on Formal Linguistics. I only regret that I cannot be with you in person. The title of my talk is Looking Ahead, Commitment Spaces for Assertions and Questions. I am working on issues related to that for the past 10 years or so, in particular in connection with the advanced ERC grant Speech Acts in Grammar and Discourse, Subacts. A short overview. I will introduce formal models of linguistic meaning and communication, in particular my framework of commitment spaces. Then I will talk about assertions in commitment spaces, in particular the modeling of reactions to assertions. We mentioned response particles and the ways of weakening and strengthening assertions. And then I will talk about questions and also focus on the modeling of reactions to questions. I think there are two breakthroughs in the study of linguistic meaning in the last century. One concerns the nature of meaning itself. According to the tradition of Frege, we can explain meanings in terms of truth conditions. With Wittgenstein we can say to understand a proposition means to know what is the case if it is true. This has been formalized within possible world semantics by Carnap. A proposition there is a mapping from possible worlds to truth values, simplified the set of possible worlds in which the proposition is true. We also have compositional semantics, stating that the meaning of complex expressions is determined by the meanings of its immediate parts, which doesn't play a major role in this talk here. An example, if we have a sentence like Lola dances, I use blue for linguistic expressions and the double brackets for the meaning. Then this is a function that maps world time indices I to truth 1 if Lola dances in I, and to falsity 0 else, so if she doesn't dance. So if this is the set of all world time indices, then this would be a subset of it, for example the set of indices for which it holds that Lola dances. The second breakthrough is the notion of communication. We have a much better understanding of communication now, namely the one that the philosopher Robert Stalnaker introduced. He says communication takes place against a background of beliefs or assumptions which are shared by the speaker and his audience and which are recognized by them to be so shared. This set of background beliefs is also called context set or common ground. And assertions or communication is now an incremental change, enrichment of this common ground. This is formalized in various notions that are known as dynamic semantics. So there the idea is that meanings are not just truth conditions, but they are dynamic in the sense that they can change information states. They are context change potentials. This applies to factual information, what is true or false, but also to the introduction of discourse reference, the entities we are talking about. Again, an example for factual information only. Let this be again the set of indices. This is the square, and the input common ground, small c, is this highlighted subset. Now we have a proposition phi, like Lola dances, that is asserted. And if accepted, then the result will be the intersection of the initial common ground, the input, and the proposition. And this will be then the output. So the proposition has been communicated. The shared knowledge of the participants is more specific now. Alternatively, we can model common grounds as sets of propositions, not as sets of indices, to assume then that an assertion introduces the asserted proposition into this set. I will follow mostly this format here, C plus phi, so we update C with phi is C union phi. Now this dynamic view has been refined in various ways. In particular, it is clear that communication is not just application of brute force, like in a board game like the board of Go, for example, where black, by placing a stone in a particular position, can capture white and white has nothing to say about it. Rather, when we communicate, we make proposals to change the information state that can be accepted or rejected One particular well-known model where this negotiating aspect is the one by Farkas and Bruce. And for Farkas and Bruce, the state of a communication is more complex than just a common ground. It consists of a common ground, C, then the commitments of the speaker S1, the commitments of the other speaker S2, and a so-called projected set, that is here the singleton set that contains the common ground. There's also another aspect in the model that I don't talk about here. So what happens if S1 makes an assertion, asserts phi, then phi becomes part of the projected set, as you see here, and also S1 is committed to phi. Phi is not part of the common ground yet. So the other speaker S2 can accept this move by saying yes, and only then phi will become part of the common ground. So first S2 has to agree to this proposition as well, and if this happens, then phi can become part of the common ground, and we remove it from the single commitments of S1 and S2 because now it became a common commitment. Now if S2 does not accept and says no, then phi does of course not become part of the common ground. So S2 is committed to not phi, and the common ground stays as it is. We have a record that S1 and S2 differ in their opinion according to whether phi is true or not. Now asking questions works like that. If S1 asks whether phi is true, we put into the projected set two options, namely C is enriched by phi or C is enriched by not phi. And now S2 can answer with yes, for example. In this case, S2 commits to phi, and phi will become part of the common ground. And of course, S2 can also commit to not phi, and then not phi will become part of the common ground. This dynamic view has been refined in various ways. For example, Sven Lauer proposed that there are various subacts when we assert. First, if S1 asserts to S2 Lola dances, there is the utterance event itself. Both S1 and S2 notice there is an utterance event. This becomes part of the common ground. Secondly, the assumption is that the addressee S2 understood what S1 says. This also becomes part of the common ground. If this is not the case, then S2 can protest with saying what, or can you repeat, in order to secure the step 2. In step 3, the proposition Lola dances becomes part of the common ground if there is a so-called credulous update. One can react here with okay, with nodding, but also reject with I don't believe this, or assert this oneself with yes. Now, but why should this third state happen at all? There is recent thought that is rooted in the work of Charles Sanders Peirce that states that it is the public commitment that the speaker S1 performs with the assertion of a proposition that is crucial. So public commitments are backed up by social sanctions if the proposition turns out to be false, especially if the speaker knew that it was false, or if this was a lie. These social sanctions are a guarantee for the addressee to assume the truth for the proposition. The social sanctions prevent a speaker from just making random assertions. And one can now look at what is happening in an assertion with magnifying lens in some sense, and relate the aspects to John Austin's parts of a speech act that I'm sure you all know. So first, the utterance event itself that Lauer also identifies is the locutionary act of Austin. So C is updated with speaker S1 utters this assertion. Then secondly, we can identify a illocutionary act that the common ground C or C prime now is updated with the proposition that S1, the speaker, is publicly committed to the proposition phi. And only then the resulting common ground is updated with the proposition phi itself. if S2 admits the proposition phi to the common ground. This is then the perlocutionary act. This is what we want to achieve with an assertion, that the proposition becomes part of the common ground. I would like to introduce here a model of communication that I worked with in the last 7 or 8 years. This is the model of commitment spaces. So it starts out with commitment states. These are simple common grounds as we had them before, sets of propositions. I call them commitment states, as commitments are the basic steps for assertive updates. So, for example, the proposition S1 is committed to phi, in short S1 turnstile phi, so I use this notation here, can be an element of such commitment states. There are integrity constraints, so there should not be direct contradictions in these commitment states. So it should not be allowed that, for example, phi and non-phi are part of the same commitment state. We could think of stronger integrity constraints, like, for example, it should be excluded that phi is in a commitment state C, and from C it follows that non-phi. Now, commitment spaces or CSs are commitment states that look ahead. They were introduced in papers by Ari Cohen and myself. So these are commitment states with continuations. So technically these are sets of commitment states. I have an example here. So we have here a commitment state C and possible continuations with the propositions phi, psi, non-phi, or non-psi. And you see this would be the first update here. This would be phi updated C. And this would be the result of updating this commitment state with psi as well. So you see we have in some sense a commitment state plus the possible continuations. And of course we cannot assume that within one commitment state there is phi and non-phi, because this would violate the integrity constraint. We have here C, this is the smallest commitment state. We call this the root, or rather this set that contains this smallest commitment state. This is the root of the commitment space C. And updating a commitment space with a proposition phi looks as follows. So starting out with the original commitment space C here, when we update this with phi, we restrict big C to those commitment states that contain phi. This means that now we have a new commitment space here with a root that is C updated with phi. This makes this update monotonous in the sense that the output commitment space C prime is a subset of the input commitment space C. Let's see how assertions can be treated in commitment spaces, and I start with the theory that I proposed in 2015. First, we need an integrity constraint that is important. It should not allow that a participant X is committed to phi and the proposition not phi are both part of a commitment state. So this would be a contradiction. This is an example commitment space. Let's familiarize ourselves with it. So here we have the root C. This is the basic commitment state. We have 5 propositions. S1 is committed to phi, phi, non-phi, psi, and non-psi. These are the updates. In particular, here we have the update S1 is committed to phi and phi. Here we would have the commitment state S1 is committed to phi and non-phi, but this is of course ruled out by this integrity constraint. And the rest are the usual combinations. Now let's look at the illocutionary act of assertion as a commitment to a proposition. We have a commitment space C, and this is updated with S1 is asserting phi. This amounts to the update of commitment space C with the proposition S1 is committed to phi with the result C prime. An example in our commitment space here. updating this commitment space C here with S1 is committed to phi results in this grayed out commitment space with a new root, namely S1 is committed to phi and of course everything that was present in C already. Now the perlocutionary act is the proposal to accept phi into the common ground. So this is then the step where C prime should be further enriched with phi, resulting in C enriched with S1 is committed to phi and phi itself. So we would have this as the result. You see this grayed out area here is basically what we have here. So if phi is accepted as well. Now what are the reactions to assertions? How can we capture the negotiating aspects? There are three possible reactions of the addressee S2. S2 can do nothing or not or say okay, and by this S2 simply accepts what S1 proposes. S2 can say yes, and this would result in a commitment by S2 to the proposition phi. And S2 can say no, and we would like to model this by saying that S2 is committed to the negation of phi. Now this is not possible to add here because of the integrity constraint. Now the idea is now to go back to the previous state of the development of the commitment spaces and then update this with that S2 is committed to not phi. And this results in a commitment space in which it is established that S1 is committed to phi and that S2 is committed to non-phi. So they disagree with each other, but this does not violate a integrity constraint. I modeled this with commitment state developments. The idea is that we have a sequence that records the development of the commitment spaces up to this point. This would be like that. Here with C plus S1 is committed to phi, and C plus S1 is committed to phi and phi. Now we try to update this with S2 is committed to not phi. This would mean updating the last element in this sequence, and this is not possible because of violation of the integrity constraint. So the idea now is that we retract to the last compatible commitment state. This is illustrated here. So this is this retraction operation that adds the next to last state on top, and at this commitment space S2 is committed to not phi can be added, resulting in this commitment space. And the important thing is the last element here. Here we have C updated with S1 is committed to phi and S2 is committed to non-phi. Now I always had the feeling that using commitment space developments is a bit of an overkill, that we can deal with reactions like no within commitment spaces themselves. And in order to do so, we have to consider certain operations on our commitment spaces. So let A and B be update functions on commitment state. So A applied to C results in C prime is the output commitment space. We typically write C plus A equals C prime. Let's look at the update of propositions. Propositions are not normally seen as update functions, but with this dot notation I can make it clear that dot phi is this update, resulting in what we had before, restricting the commitment space C to those commitment states that contain phi in C. Now let's look as an example at this commitment space here. The root C can be updated with phi, pi, non-pi and psi and all the subsequent combinations. Now let's look at one operation, incremental conjunction. C updated with A and B is the same as C updated with A followed with the update by B. Looking at an example, so we have here the update of our commitment space first with phi and then with psi. The second operation is Boolean conjunction, which looks quite similar. C updated with A and B is C updated with A intersected with C updated with B. Here you see The update with phi would be this set, the update with psi would be this set, and we get as a result the intersection of both updates. In this case we have the same result as with the incremental conjunction. This might be different once we consider discourse reference. Then we have Boolean disjunction. C updated with A or B is C updated with A, the union with C updated with B. So the update of our commitment space with phi or psi results in this set here. Notice that this is a commitment space that has two commitment states in its root. It's a multiple rooted commitment space. And finally we have denegation. So C updated with the denegation of A is C minus C updated with A. This would be the update with phi, as we have seen before. And the denegation of phi is the rest in some sense. It's this commitment space. Notice that the root of the original commitment space does not change with denegations. Now let us apply these operations for a theory of no without retraction. We start with this commitment space here. It has a root C and updates with S1 is committed to phi, S2 committed to phi, S2 committed to non-phi, and then I throw in some propositions phi, non-phi, psi, non-psi. These are the combinations that we have here. Obviously we have to follow the integrity constraint that S1 is committed to phi and non-phi cannot be part of the same commitment state. Now S1 declares commitment to phi, and the result is this gray commitment space with S1 committed to phi at the root. S1 also wants to make phi part of the common ground, and so we have the conjunction with phi, and the resulting commitment space is the gray area here. Now the novel thing is that we take care for the possibility that S2 rejects phi. So this means that S2 commits to non-phi. We express this as a disjunction, and the result is a commitment space, the gray area here, that has a root with two commitment states, S1 committed to phi and phi, or S2 committed to non-phi. Then this is the overall effect of the assertion by S1 of phi. It takes into account the possibility that S2 rejects phi. Now let's look at the possible reactions of S2, the addressee. One option is that S2 just accepts the move and says OK. Now acceptance is expressed here as an update with a denegation that S2 commits to non-phi. So this means that S2 refrains from being committed to non-phi. The resulting commitment space is this. You see that in all states phi is established. In some states S2 might be committed to phi, in some not, but in all states phi is established, and in all states S1 is committed to phi. This expresses that S2 does not have anything against assuming phi, and as S1 is committed to phi, phi gets established in the commitment space. Now let's look at the second reaction. Yes, in this case S2 commits to phi, with the result that we have a commitment space in which both S1 and S2 are committed to phi, and of course phi is also part of this commitment space. And now what about no? With no, S2 commits to non-phi, with the result of this commitment space here, in which S1 is committed to phi, S2 is committed to non-phi, and of course in this situation phi cannot be established. Now let's recapitulate. With an assertion of phi, S1 commits to phi and tries to establish phi. But this depends on the reaction of the addressee. So S2 can also commit to non-phi, and we express this by a disjunction. Now this results in a commitment space with two elements in the root. This is a non-optimal situation, which can be resolved either by S2 indicating agreement in the sense of refraining from an objection. So this would be the update with the denegation that S2 commits to non-phi, or by yes, in this case S2 commits to phi as well, or by no, in this case S2 commits to non-phi, and in this way phi is not established in the commitment space. There's no separate table necessary as in Farkas and Bruce, and there's no rejection operation necessary as in Krifka 2015. Now, one can retract an assertion in the sense of retracting a commitment, his or her own commitment. So if S1 says Lola runs, S2 says no she doesn't, S1 says she does, and S2 says okay, you are right. A situation that was described by Merin. We can model this by assuming an option of a participant S to retract a previous commitment. So how does this look like? Assume an input, a commitment space C, and a retraction of S of his own commitment to phi. This should be possible because a speaker is master of a commitment. Let's have a quick glimpse on the working of response particles. So the idea here is that the antecedent clause introduces a propositional discourse referent that is picked up. So for example, Lola won the prize. If S1 asserts this, there is a propositional discourse referent P that is assigned to the proposition Lola won the prize. Now, responses like okay, yes, and no can pick up this propositional discourse referent that stands for a proposition, and we get the reactions as we have seen before. And there's also a possibility to treat the strange things that are going on once the antecedent clause is negated, as in Lola didn't win the prize, because then we can assume that a non-negated discourse referent P and a negated discourse referent Q is introduced, and this can be picked up. So this leads then to the result that, well, in the case of OK it's still fine, but with yes, yes can either pick up P or Q, and the answer yes will have different impact according to that, and similarly no can pick up P or Q. And there might be certain blocking effects, as we've argued in experimental work. This is the article by Klaus et al. So we know that there are different tendencies in European languages and East Asian languages in which discourse referent is to be picked up here, but in principle we can deal with the meaning of response particles as anaphoric expressions that pick up propositional discourse referents introduced by the antecedent clause. I will now talk about fine-tuning assertions, weakening or strengthening them. First, there are ways of weakening assertions by epistemic operators. I can say Lola certainly will win the prize, or Lola probably or possibly will win the prize using epistemic adverbs. I can use epistemic lifting constructions like Lola will win the prize, I think. And I can use epistemic verbs as in Lola is happy, she must have won the prize. We can analyze these cases by assuming that they express our commitment to a subjective epistemic attitude. So the idea is as follows. With Lola certainly will win the prize, C is updated by a commitment of S1 to the proposition that S1 is certain that Lola will win the prize. So this proposition is easier to defend. S1 can say, well, I was certain about it. It turned out to be wrong, but I was certain about it. Nevertheless, it is the proposition Lola will win the prize that is meant to be put into the commitment space. This explains why such cases don't allow for negation. I cannot say uncertainly Lola runs or Lola runs, I don't think. This is because a commitment to a proposition, it's not the case that S1 is certain that phi, does not provide enough backup for the proposition phi itself, and so systematically negation is not possible here. There is an alternative explanation by Murray and Starr. They assume that the proposition Lola will win the prize is put as a discourse referent to be taken up, and so therefore this is the goal of communicating this proposition. However, we have to distinguish between subjective and objective epistemic operators. They differ in particular with respect to the negation. I can say it is uncertain that Lola will win the prize, this is perfect, or it is not certain that Lola will win the prize. And in this case, I suggest that the judgment of certainty is part of the communicated proposition, and it's not necessarily the speaker, but it refers to some trustworthy source itself. And so the proposition that there is a trustworthy source that considers phi certain is communicated. Another case how assertions can be modified are evidentials. There are sensory evidentials, in English for example, Lola apparently won the prize, or Lola won the prize it seems. I assume here that in this case the commitment is to the evidence for a proposition. Again, this is easier to defend, therefore these assertions are considered weaker. So in Lola apparently won the prize, the speaker S1 commits to S1, has evidence that Lola will win the prize. Still, the proposition Lola will win the prize itself is forwarded. There are also reportative evidentials, as in according to Bill, Lola won the prize, or Lola won the prize, Bill says. In this case, the speaker proposes that Bill, the reportative source, is committed to Lola won the prize, and by this, if Bill is a trustworthy source, the proposition Lola won the prize itself can be put into the common ground. This is the goal of such speech acts. So the commitment is shifted to another person. I've called this proxy speech acts. This kind of evidentiality can be contradicted as observed by Faller and Murray and Starr. An example is here, according to Bill, Lola won the prize, but I don't think so. This is coherent. What happens here is that the speaker introduces Bill's commitment to phi, and at the same time that S1, the speaker, is committed that S1 does not believe phi, and due to integrity constraints, phi will not become part of the commitment space. There are also ways of strengthening assertions. Examples are Lola definitely won the prize, Lola won the prize, I swear, or by God, Lola won the prize. How can we model such strong assertions? I think that there are strength differences in the assertive operator, the turnstile operator. Something like this has been proposed by Searle and van der Veken. So let's assume this strong operator that supports a proposition phi more than the standard operator. What is the effect of strengthening here? Well, in general, the social sanctions should be greater if the proposition turns out to be false, like loss of faith or maybe other legal consequences in the case of swearing. By this, strong commitments can generate greater trust and hence might be used to improve the acceptance of propositions. And contradicting a strong commitment should be a more risky communicative act. Let us finally turn to questions. What's a question? With a question, a speaker wants an assertion of a particular type, an answer from the addressee. We can model this by a restriction. The speaker restricts the possible continuations of the commitment space to answers. This was the idea in my modeling in 2015. Let's look at a so-called monopolar, a biased question. This is a simple question like, did Lola dance? Here the speaker S1 restricts the continuations to assertions of S2 of phi, and the root of the input commitment space stays the same. The continuations are restricted. The example for that, if we have this as an input commitment space with various immediate propositions here, S2 is committed to phi, S2 is committed to non-phi, and so on, then the question, did Lola dance, asks whether S2 is committed to phi, and this would be the restriction here. The root would not change, but the continuation is restricted to the commitment of S2 to phi. If the addressee says yes, we have the situation that S2 actually does commit to phi. Yeah, and we have this kind of continuation then, and phi gets established. If the addressee says no, then this cannot be interpreted with respect to the question, because this does not provide for S2 being committed to not phi. So this means that we have to go back again. We have to retract our steps to the original commitment space, and then the speaker commits to non-phi. So, and we get this result. Now we want to explore whether retraction is necessary. Can we provide for unexpected responses in other ways as well? So one possibility is the following. The question, did Lola dance, provides for the possibility that S2 does not commit to phi, so for the denegation of this possibility. So this is the disjunction sign, so this is the taking care of the possibility that S2 does not go along. Let's assume our commitment space again. The question in this interpretation has this meaning. It accounts in this region here for the possibility that S2 does not commit to phi. In the case S2 says yes, then we get the same result as before. So S2 commits to phi and phi gets established. If S2 says no, we get the following result. In this case, we don't need any retraction, and S2 can commit to not phi, and not phi gets established. We can also account for other reactions like I don't know, in which case the statement that S2 is committed to not knowing that phi, this excludes that S2 is committed to phi, or that S2 is committed to non-phi by plausible integrity constraints. So there is a bias towards a positive answer in this case, because the question meaning here states that as soon as S2 is committed to phi, then phi is established as well. So there's still this bias here to a positive answer. We can now look at other questions like alternative questions. Did Lola dance or not? These are analyzed as a disjunction of S2 committing to phi or S2 committing to non-phi, thus introducing phi and non-phi respectively. In our case, we would have this meaning. You see this disjunction. There are two possible continuations. Now the answer yes and no are equally possible. There is no real difference between them. But there are also other responses like I don't know that we have to account for. And we can account for that in this way, that we state that in case the answer yes or no is not possible, this is an option as well. This would result then in this configuration, where on this side here, these are the areas where phi, where the speaker S2 does not commit to phi or to non-phi. In general, the strategy here is that we have to provide for cases in which the addressee S2 does not proceed as initially suggested. And the same happens with constituent questions. Semantically, constituent questions are just like alternative questions, except that the alternatives are introduced in different ways. So in the question who danced, for example, if the alternatives are Lola and Max, this amounts to the question did Lola dance or did Max dance? And again, we have to provide for the possibility that neither one of these options is taken up by the addressee. In general, constituent questions look like that. We have a set of propositions Q, and the question is formed over all the propositions in Q. I should point out that I've treated other types of questions in various works. For example, high negation questions like didn't Lola dance? In this case, the negation is in front of the commitment, and this creates the specific bias profile of such questions. Or declarative questions of the type Lola danced. In this case, the speaker S1 checks whether he or she is allowed to commit to phi, whether the addressee agrees with that. Then deliberative questions that are not supposed to be answered, like in English, I wonder whether Lola danced, or German has a specific possibility for this, ob Lola wohl getanzt hat. In this case, there's no commitment of the addressee involved, but just the issue whether phi or non-phi is the case is raised. Then there are question tags of different types, the reversing type, Lola danced, didn't she, and the matching type, Lola danced, did she. And in this case, we can express this by a disjunction of an assertion and a high negation question in the first case, and is a conjunction of a assertion by S1 and a question whether the addressee agrees with that. Again, the different bias profiles can be explained in this way. And I've also worked on focus and contrastive topic in questions, in particular in an article with Beste Kamali on such questions in Turkish. What I've proposed here is a novel way of dealing with preferred and dispreferred discourse continuations. So with assertions, the preferred continuation is acceptance. With questions, the preferred continuation is an assertion by the addressee. This is similar to adjacency pairs in conversation analysis, where we have greetings and greeting back, promises and uptake or denial of these promises. What I suggested here is a new way of taking care of the non-preferred moves. Instead of retracting to a previous discourse state, as I proposed earlier, I investigated how we can provide for the non-preferred continuations by something like an else clause, an else continuation. If the preferred continuation is C updated by A, then the else clause is something like C updated by A, and if not A, then B, or simpler A or B, where B is the unpreferred move. For assertions, we have something like that. The preferred move is that S1 commits to phi and phi becomes part of the common ground, but there could be an objection by S2. This is the else clause. For questions, the preferred move is that the addressee answers the question. The non-preferred move here is that S2 has an objection to uttering one of the preferred moves, one of the straight answers. A possible disadvantage of this is that there is no formal difference between the preferred continuation and the dispreferred continuation. On the level of the structures, the else condition doesn't look different from the preferred continuation. Wrapping up, I've talked about theories that treat communication as changing common ground. I've introduced the commitment space model as a model of common ground with a look ahead feature, modeling the expectations that are generated by certain speech acts like assertions and questions. And I've shown how to accommodate for various reactions to expectations, including the non-preferred ones like denying an assertion or not answering a question. Thank you very much.